morning to one and all. This is G.Harshini from Gokaraju Rangaraju Institute of Engineering and Technology, Hyderabad. First of all, thank you for International Conference on Inventive Computational Technologies for giving us such a wonderful opportunity to attend this conference. Our project title is Machine Learning Approach for Various Eye Disease Using Modified Voting Classifier Model. My teammates are Dinesh Saradi and Fani Kumar. We have successfully completed this project under the guidance of Vijay Kumar sir. Contents are introduction, literature survey, machine learning and deep learning methods, proposed methods, methodology, result analysis, graphs, comparison between different models, conclusion, future scope, and differences. Introduction. Various eye diseases like cataracts, glaucoma, diabetic retinopathy, etc., using machine learning and deep learning techniques to detect the diseases. As we see the various diseases, one of that is cataracts. Cataracts scatters and blocks the light as it passes through the lens, preventing a sharply defined images from reaching retina. As a result, vision becomes blurred. This may cause the blindness. Detecting and diagnosing these diseases early on is crucial for effective treatment and the preservation of vision. Classifiers such as SVM, random forest, voting classifier, mobile net, Inception V3 have been utilized to analyze eye images and accurate detect the presence of these diseases. Coming to the literature survey, the title of the paper is Multiple Label Classification of Fundal Images with Effective Net. In this paper, the methodology used is the main idea of the assembly learning is to integrate the multiple weak classifiers to obtain the better and more comprehensive strong classifiers. As we see in the result, accuracy rate is 89%. Then coming to the next title of the page, eye disease detection using machine learning. In this, the methodology used is random forest, gradient boosting, and support vector machine algorithms are used for detection. As we see in the results, for the gradient boosting proves to the best results for the eye diseases with cataracts with 90% accuracy, whereas others give 89 and 86 respectively. The title of the paper of next paper is Source and Camera Independent Ophthalmic Disease Recognition from Fundal Images Using Neural Networks. The methodology used in is CNN algorithm, and result we have obtained is 80.5%. The next title of the paper is Automatic Ocular Disease Screening and Monitoring Using Hybrid Cloud System, where the methodology used is SVM methodology. In this SVM methodology, they are also using the web portals and mobile application IoT and APIs, where the result obtained for this SVM methodology is 79%. As we moving to the next slide, where the next slide is machine learning and deep learning methods. We know that machine learning and deep learning are the artificial intelligence, one of the artificial intelligence part. In this machine learning, we are using SVM and random forest and voting classifier. In this deep learning, we are using mobile net and Inception V3. Whereas both machine learning and deep learning are the branches of the artificial intelligence, involving the use of the data to train the models, and they are in different of architecture, complexity, data requirement, computation resources, and application areas, where the machine learning models are the typically simpler and more interpretable, where the deep learning are the more complex and suitable for the task that requires the capture of complex patterns. In deep learning algorithm, we are using CNN models, where these are MobileNet and VGG, Inceptive V3, and many other few CNN models also present. And next slide, we are going to voting classifier. In this voting classifier, it is an example for assembly learning techniques that combines the prediction from various separate classifiers to increase the precision of final prediction. A set of machine learning algorithms known as assembly learning combines the numerous models to provide a singular prediction. As a result, the voting classifier is the member of the machine learning approach family known as assembly learning, whereas GBDT, XGB, and decision tree classifiers can all be put together with a voting classifier. The idea behind a voting classifier is that by combining the predictions of several different classifiers that resulting Model can be more accurate and less prone to overfitting than any other singular alone. There are main types of voting classifiers in the voting classifier: hard voting and voting. In the voting classifier, classification is achieved by combining the prediction of multiple individual classifiers. The voting classifier machine learning can be used for both classification and regression tasks. In the classification task, the voting classifier combines the prediction class labels from the different base classifiers to determine the final predicted class label. In the regression task, the voting classifier can combine the prediction of numerical values from different base classifier to obtain the final regression prediction. Whereas the advantages of voting classifier is it can achieve the higher accuracy compared to the individual base classifier, and it combines the prediction of multiple classifiers which help us to reduce the bias and variance error. It can improve overall prediction performance, and it gives the more accuracy compared to other classifiers, and it can approach both classification and decision tasks with a flexible approach. Whereas architecture of the voting classifier, we know that we data can be collected and it can be pre-processed, and whereas these three algorithms like gradient boosting decision tree, extreme gradient boosting, where these three are trained and tested, these three outputs can be compared and combined through voting classifier. It can make the final decision according to it. Coming to SVM algorithm, it is a support vector machine. It is a popular machine learning algorithm which is used for classification and decision tasks. It is a supervised learned method that can used for both binary and multi-classes classification problems. In SVM, the goal is to find the hyperline that best separates the data points into different classes. The hyperline is chosen maximize the margin, which is distance between the hyperline and closed data points of each class, known as support vectors. One of the key features of SVM is uses of kernel, which allows the algorithm to operate in a high dimensional feature space without explicitly computing the feature vectors. This allows the SVM to capture complex non-linear relationship between the features, making it highly flexible for various types of data. Next, random forest algorithm. It is a assembler classification that utilizes a collection of decision trees to make the prediction based on a majority of voting from these trees. This approach outperforms individual decisions tree classifiers, where utilizes the bagging techniques to train each tree by randomly selecting a subset of training data features. As we seen that the random forest is an machine learning technique, and where it can classify and decision the task. As we moving to the next, MobileNet. MobileNet is a deep learning architecture that's specifically designed for the efficient deployment on the mobile and the embedded devices. It is a type of convolution neural networks, which is known as CNN, that is optimized for low computational requirements and small memory footprint, and real performance makes it well suited for mobile and edge computing environment. MobileNet comes in different versions, such as MobileNet V1, MobileNet V2, and MobileNet V3, each with its own improvements and optimizations. Whereas it is widely used in various applications like object detection and image classification, face recognition, visual search, and among others. Next, we are moving to Inception V3 algorithm. It is also a deep learning architecture, and it is used for image recognition and specifically designed for the computer vision tasks such as image classification or object detection. It is a transverse learning, which is the retraining of pre-trained model on a new model, which using a small amount of dataset to reduce the training time and boosting time has grown to one main strategist improved in Inception V3 for image categorization. Next, methodology. In this methodology, we have seen that data collection and image processing and creating a model, where in this creating model we have tested and trained and building the random forest algorithm, SVM algorithm, voting classifier, inception, and mobile net, where these are classified as normal and cataract diseases, glaucoma disease, diabetic retinopathy disease, myopia disease, age-related macular degeneration disease, and other diseases. And finally, it gives the prediction about these results. As we know that this model will train for 20 epicodes, which their ratio of 1 is to 3, whereas this 1 is to 3 is the ratio of training and testing data, where we are taking testing data is 1 is to 1%, as we take training as 3%. The accuracy level during the training and testing for each epico is 198.79 respectively. For each epicos, the training and testing loss values are 0.015 and 0.294 respectively. The proposed method is proven that to be a more efficient when compared to other CN methods such as Inceptive V3 with an accuracy of 73.47 accuracy, MobileNet with 87.35% accuracy, and other deep learning methods like SVM with accuracy of 74.57 and random forest with 74.57 accuracy. As we see in the graphs, the left side graph is voting classifier graph. It shows us the accuracy of voting classifier is 0, 9, 98, 98.79%, and whereas random forest we have seen that the accuracy of this is 74.84 percentage. Comparison between different models. In these, we are using 5 models like random forest, voting classifier, SVM, MobileNet, Inception with. Firstly, random forest, it obtained the accuracy 74.57, whereas recall as 0.72, precision 0.69, specify 0.75, F1 score is 0.7. Whereas voting classifier obtained accuracy 98.79%, recall has 0.97, precision as 0.93, specify as 0.98, F1 as 0.98. As we see in SVM support vector mission, accuracy is 74.57, whereas recall as 0.78, precision as 0.72, specify as 0.77, F1 as 0.78. As is in MobileNet also, obtain 87.35, whereas recall as 0.83, precision as 0.79, specify as 0.87, F1 score is 0.86. As we see in Inception V3, this is having an accuracy of 73.47, whereas recall as 0.69, precision as 0.64, specify as 0.74, F1 score is 0.70. As we move into the conclusion, this is a modified version of voting classifier model as our suggestion. Additional layers we are adding to the initial model to produce the proposed model. Our existing data was laterally split into the training and testing data after explanatory data analysis. As the result feeding the model testing information, the high level of testing accuracy is 98.79 has been generated. Our study's outcome clearly demonstrate that the suggested techniques may indeed improve on the labeled data. Our future scope. The future version of the proposed system may include an expand user interface that would allow user to upload the photos and determine the types of elements in the order to obtain outstanding performance. Certain measures must be improved. As we seen that these are the references has been taken, and thank you.